The climate crisis is here, no doubt about it. And
Oh.
the idea of a swift technological fix like geoengineering is undeniably tempting.
It really is.
Last time, we dove into what exactly geoengineering entails and who's funding these, well, pretty ambitious plans.
Yeah, the background.
Today, we're tackling the big what if. What could actually happen if we, deploy these technologies? Could they pull us back from the brink, or might we be stumbling into a whole new set of problems you'll have to deal with?
That's really the crucial question, isn't it? We need to unpack that. The urgency driving this whole conversation is very real.
You think back to James Hansen's warning.
Yeah.
Was it 1988?
Exactly. Way back in 1988. And now climate models suggest we could blow past that critical 1.5 degrees Celsius warming mark, maybe even within this decade.
This decade, wow.
And potentially hit 2 degrees Celsius by mid-century.
And if we cross those thresholds, I mean, the picture science paints isn't pretty for you listening.
No, it's quite stark.
We're talking about a serious escalation in extreme weather, more intense heat waves, much longer droughts.
Devastating floods, yeah.
Rising sea levels, threatening coastal communities, widespread extinctions.
It affects everything. Plants, animals.
Crop failures, leading to food shortages.
Yeah.
And those really scary tipping points that could trigger, irreversible changes.
Exactly. Those feedback loops.
So faced with that kind of future, it's understandable why the prospect of a rapid intervention like geoengineering looks so appealing.
Absolutely. And stratospheric aerosol injection, or SAI, that's one of the most talked about options for getting that rapid cooling.
Right. The timescale's the big draw, isn't it?
That's what's so compelling. We could potentially see a cooling effect within months.
Months, which is just worlds away from the decades it takes for cutting carbon emissions to really make a dent in global temperatures.
It's a stark contrast, absolutely.
And the initial promise, well, according to researchers at Harvard's Solar Geoengineering Research Program, it sounds like a potential win on several fronts.
What are they suggesting?
They suggest SAI could lower sea surface temperatures, maybe saving coral reefs.
Okay, that's significant.
It might also give struggling species a bit more time to adapt instead of, frantically migrating.
Buying time, essentially.
And maybe even slow down the melting of sea ice and glaciers. It's that hope for immediate relief when the long-term solutions feel, so long-term. So let's say SAI worked perfectly, just hypothetically. What are the biggest positives we could realistically expect for the planet and for you listening?
Well, in that best-case scenario, that rapid cooling could indeed provide a crucial buffer. It could mitigate some of the most immediate and severe impacts of the warming we're already locked into.
Like less extreme heat.
We might see a temporary reprieve from record-breaking heat, yeah. A slowing of that ice melt could buy coastal communities more time.
Okay.
And maybe a reduction in the thermal stress on sensitive ecosystems, like those coral reefs you mentioned.
Okay, so there's definitely an allure to that rapid action. But we've got to dig into the potential downsides, and it sounds like there are some pretty significant complexities.
Indeed. While that potential for rapid cooling is there, it's absolutely critical to understand that SAI isn't a magic bullet. It doesn't address the root cause.
Which is the greenhouse gases themselves.
Exactly. The excess greenhouse gas is already up there in our atmosphere.
It's like treating the symptom but not the disease, right? Bringing the fever down, but whatever's causing it is still doing damage.
That's a very accurate analogy. SAI acts like a temporary shade, basically. It reflects some sunlight back into space to lower temperatures.
But does nothing about the CO2 concentration.
Nothing at all. And that leads us straight to a major concern: ocean acidification.
Because that's a direct result of the ocean soaking up all that extra CO2 we're pumping out. And SAI just leaves that problem completely untouched.
Precisely. The oceans just keep absorbing CO2, keep getting more acidic.
Which has devastating consequences for marine life, shellfish, coral reefs.
It disrupts the entire marine food web, really.
Okay, so that's one major issue. What else?
Well, beyond that, climate models suggest some pretty worrying changes to rainfall patterns.
Ah, right. This really highlights that we're talking about tinkering with a massive interconnected system. It's not just about a global average temperature.
Not at all.
The regional impacts could be incredibly varied, right?
Exactly. Studies indicate SAI could significantly alter where rain falls and how much falls globally.
So some places might get more rain.
Possibly. But other areas could face severe and prolonged droughts.
Like where?
For example, a study involving NOAA, Cornell, and Indiana University. They suggested that using enough SAI to counteract warming from, say, quadrupled CO2.
Which is a lot.
A huge amount, yeah.
What?
Could lead to something like a 5 to 7% reduction in rainfall in parts of the tropics.
Only 5 to 7%. Doesn't sound like that much initially.
Well, but think about the impact. That could have devastating consequences for agriculture, for rainforests in those regions.
All right. You're trying to cool the planet, but are you inadvertently setting the stage for widespread famine in some very vulnerable places?
That's the chilling question, isn't it? It goes way beyond just a percentage drop.
A fix in one place, causing a potential crisis somewhere else.
Yeah.
That sounds incredibly difficult to manage globally.
It is, and the regional impacts could be quite specific, even counterintuitive.
How so?
Well, one model looked at deploying SAI over the Indian Ocean. The idea was to try and help with drought in the Sahel region of North Africa.
Okay. Sounds logical, maybe.
But surprisingly, the results suggested this could actually make drought worse in East Africa.
Wow. So completely unintended consequences.
It just really underscores how intricate and interconnected our climate system is. Pull one lever here and something unexpected happens way over there.
And the potential risks don't stop with rain, do they? There's also the very worrying possibility of damage to the ozone layer.
Yes, that's another big one. The ozone layer up in the stratosphere, it's vital. Protects us from harmful UV radiation from the sun.
We all learned about the ozone hole.
Exactly. And a recent NOAA study looked at various proposed SAI strategies. They found that all of them led to a significant reduction in ozone over Antarctica.
All of them.
All the ones they examined, yes. Though the specific chemical reasons differed depending on the approach.
How does that happen?
Basically, certain chemical reactions involving the particles you inject can break down ozone molecules up there, weakening that protective shield.
Which obviously has major implications for human health, skin cancer, cataracts.
And then there's this concept called the termination problem, which honestly sounds quite alarming.
It does sound bad. What is it?
It's a deeply concerning aspect. If we were to implement SAI, get things cooler, and then for whatever reason suddenly had to stop.
Like political reasons or economic collapse.
Could be anything. Political instability, economic issues, maybe just a change in global priorities. If you stop injecting those aerosols, the cooling effect they provide disappears very, very quickly.
So the temperature would shoot back up.
Exactly. You could get a sudden, potentially catastrophic surge in global temperatures. It would essentially unleash all the warming that had been temporarily masked by the aerosols.
That is terrifying. It's like becoming reliant on a technology where failure triggers an even bigger disaster.
It does make you wonder, doesn't it, about the maybe hubris of thinking we can just easily tweak a system as complex as our entire planet's climate.
So we could be locked into this technology indefinitely with potentially devastating consequences if we ever had to stop. It really underscores that SAI isn't some simple standalone solution.
Not by a long shot.
Now, the sources also point out, importantly, that not all geoengineering approaches are the same. Their consequences can vary quite a bit.
That's a crucial distinction, yeah. The specific method we choose to try and influence the climate system will have significant and, importantly, varying impacts.
Okay, like what?
Well, a 2023 study in atmospheric chemistry and physics looked at different ways of injecting sulfur dioxide. Where you inject it matters.
Ah, location.
Yeah.
Even in the stratosphere.
Apparently so. They found injecting near the equator in the tropics tended to produce more undesirable side effects.
Jazz?
Things like warming in Eurasia during the winter, and again, that reduction in rainfall in the tropics, which are already vulnerable.
Okay, so tropical injection might be worse. What about other locations?
Injecting at mid-latitudes or closer to the poles seemed to lessen those specific effects in their models.
Interesting. So where we deploy these aerosols really matters.
Yeah.
But even with those adjustments in location, were there still some overarching concerns that remained?
Yes. Notably, that study found that no matter which sulfur dioxide injection strategy they looked at, there was still a significant reduction in ozone over Antarctica.
So the ozone problem didn't go away just by changing location.
Nope. It really highlights the intricate balance, as the lead researcher Ewa Bednarz put it, the fine interplay of radiative, dynamical, and chemical processes that control how circulation and ozone react to SAI.
Complex stuff.
Very.
And the research is constantly evolving, right? I saw the sources mention exploring alternatives to using sulfur dioxide.
Indeed. Things move fast in this field. A February 2025 study, quite recent, in Nature's Communications Earth and Environment investigated using solid particles instead.
Like what kind of particles?
Things like alumina and calcite.
And what did they find? Any advantages?
The findings suggested some potentially promising advantages compared to sulfur dioxide. A big one was a significant reduction in stratospheric warming.
Oh, right, because the sulfur particles absorb heat up there.
Exactly. But these alternative particles might reduce that warming by as much as 70%, and they could also increase diffused solar radiation, maybe up to 40%.
Okay, unpack that a bit. Why is reducing stratospheric warming important?
Well, as we touched on, warming the stratosphere with sulfur-based SAI can actually disrupt atmospheric circulation patterns.
And mess with the weather, the rainfall.
Precisely.
Yeah.
So these alternative particles, by warming the stratosphere less, might offer a way to lessen some of those risks, fewer disruptions.
That sounds potentially better then.
That's the hope, yes. It's still an active area of research, but it shows that the material you use for solar radiation management could have a substantial impact on the consequences. It's not just about if you do it, but how.
Now, shifting focus slightly, one aspect that keeps coming up as really fundamental is the potential impact on water. The global hydrological cycle. That seems absolutely critical.
It is. Water is just fundamental for life on Earth. Any large-scale intervention in the climate system could have profound consequences for how water moves around our planet.
And what's the general expectation there?
Research highlighted in the annual review of Earth and Planetary Sciences suggests that most solar geoengineering approaches are expected to weaken the global hydrologic cycle overall.
Weaken it. What does that mean practically?
It generally implies less evaporation, which means less precipitation overall,
Sure.
potentially less fresh water available in many regions across the globe.
A global weakening of the water cycle.
Mm-hmm.
That sounds like a very serious potential outcome.
Mm-hmm.
But again, I assume it's not a uniform effect.
No, definitely not. That's the recurring theme. Some areas might actually end up with more rainfall, while others face even greater water scarcity.
Which is crucial for you listening, especially if you rely on consistent rainfall for agriculture, or even just for your daily water supply.
That's correct. The regional variations are a major source of uncertainty and, frankly, concern. While the global trend might point one way, specific locations could see increased rainfall, while others are pushed towards more severe, prolonged droughts.
And the real challenge is predicting that accurately.
That's it. Our ability to predict these specific regional impacts with enough accuracy to make truly informed decisions is still quite limited.
And that lack of predictability, that raises some incredibly complex ethical and governance questions, doesn't it?
Oh, absolutely.
If one country's geoengineering efforts, say, lead to a drought in another country, who's responsible? How do you even begin to address accountability, compensation?
Exactly. The potential for these uneven regional impacts raises fundamental questions about fairness. Who gets to decide which regions might benefit and which might suffer negative consequences?
Right.
How do we establish responsibility? How do you provide remedies if someone else's geoengineering activity harms you? These are deeply complex issues with no easy solutions in sight.
Now, before we wrap up this part of the discussion, I wanted to touch on another technique mentioned. Marine cloud brightening. This sounds a bit different.
It is, yeah. Marine cloud brightening, or MCB.
It seems like it could be a more targeted approach, focused on clouds over the ocean.
That's the idea. It involves spraying tiny sea salt particles into low-lying marine clouds. The goal is to increase their reflectivity.
Make them brighter.
Essentially, yes, make them brighter so they reflect more sunlight back into space. It could potentially offer a way to cool specific areas.
Like trying to protect vulnerable coral reefs from getting too warm.
That's one potential application, yes. Targeted cooling for sensitive ecosystems.
Okay, interesting. And there was a really surprising finding mentioned about how MCB might actually interact with the stratospheric stuff, with SAI, something unexpected.
Indeed. A March 2025 NOAA study revealed this potential indirect interaction. They found that injecting particles way up in the stratosphere could, counterintuitively, enhance the reflectivity of those marine clouds thousands of feet below.
Really? How much?
According to researcher Jake Gristy, the effect could be much larger than we anticipated. They estimated reflectivity could potentially increase by as much as 10%.
10% is pretty significant and totally unexpected.
Apparently so. It really highlights just how interconnected everything is, and in many ways, how poorly understood our climate system still is in some respects.
We might think we're targeting one specific layer or process.
But there can be these unintended ripple effects across the entire system, knock-on effects we didn't foresee.
That example really underscores the complexity, doesn't it?
Right.
And the potential for unforeseen consequences when we try to intervene on such a massive scale.
Precisely. It reinforces the need for extreme caution, for really thorough research, before we even seriously consider the widespread deployment of any of these powerful technologies.
So as we wrap up this deep dive for today, it
Yeah.
seems the picture is, well, far from clear-cut.
Definitely murky.
While geoengineering, particularly something like SAI, holds out this tempting possibility of rapid cooling in what feels like a climate emergency,
The allure is strong.
it comes with this significant baggage, doesn't it? A whole suitcase full of potential risks and massive uncertainties,
Mhm.
from altering fundamental weather patterns,
Hmm.
potentially damaging the ozone layer, to creating these profound regional inequalities we talked about.
And the termination risk hanging over it all.
Right, and even within the different proposed techniques, the consequences can vary quite dramatically.
Yeah.
It's certainly not like there's one single, straightforward, perfect solution that's emerged from the research we've looked at today.
That's a concise and very accurate summary. Our scientific understanding of the potential consequences, it's still developing. But the potential for significant and potentially detrimental side effects is a major concern that needs really careful consideration.
Which brings us perfectly to our next deep dive. We've now explored the what of geoengineering and the potential what-if scenarios, the consequences. Next time, we're going to get into the really challenging questions.
The governance and ethics.
Exactly. The scientific controversies that still exist, and the incredibly complex issues around decision-making and governance. Who gets to decide if these technologies are used, and how?
What are the international challenges when one country's actions could affect the entire planet?
And what are the implications if a single nation, or maybe even a private company, decides to just go ahead and do it unilaterally?
Huge questions.
So join us next time as we grapple with those crucial issues. Until then, it's worth keeping in mind the immense power we're contemplating here, and the profound responsibility that comes with even thinking about wielding it.